So let's take a look at some examples. These are the problems from the assignment. A cup of tea cools at a rate which varies exponentially based on several factors. The thermal properties of the cup, obviously, if it's better insulated or not, it's going to change things. Mostly it's the comparison between the temperature of the tea or coffee or whatever hot beverage you've got compared to the surrounding air. So the hotter the tea is, the faster it cools off. And then as the temperature of the tea is closer to the surrounding temperature, it doesn't cool off as much. So you get that exponential curve coming down. So it would look like exponential decay. Okay, anyway, the temperature of Ricardo's cup of tea is given by this equation. This is the bigger version of the equation. Where T is our variable, hiding right there is our variable measured in minutes. Okay, so part A, I've already got all my work written out, so you don't have to wait for me to write all this stuff down. But part A, what is the temperature of Ricardo's tea when it was first poured? When it was first poured, that means no time has passed. So time is going to be 0. So I'm going to take 0, we'll just put it into our equation instead of T. Two options. One, just take that whole equation, type it into your calculator, get your answer. It's 199. Or you could actually do this mentally. It's not very hard. 0 goes in here as the exponent. Start from the exponent. Negative 0.04 times 0. That gives us an exponent of 0. E to the power of 0. That's 1. Anything to the power of 0 is 1. 130 times 1 is 130. So really, this is just 69 plus 130. Right? That's not hard to do mentally, but calculate it if you want. So it's 199. There's the starting temperature, and then it's going to cool off from there. Part B, different amount of minutes, probably not something you're going to do with mental math with the 5 or whatever number you've got. Drop the 5 into your equation, put it on your calculator, get your answer. Let's look at C. This is where we start solving. So Ricardo likes their tea just warmer than room temperature. After how many minutes was the temperature of their tea? 98.6 degrees. Okay, so I'm going to take that 98.6. That's going to be my output, my function value. 98.6 goes here. Bring the rest of the equation. And then we need to solve for t. Okay, when you're solving an exponential equation, the exact same approach as if we're solving a logarithmic equation. If the variable is trapped inside of a log, or in this case, if it's trapped inside of an exponent, isolate that exponent, the base and the exponent. So the 69 needs to go away, the 130 needs to go away, a couple of algebra steps, subtract the 69, divide by the 130, and that gets us to where we have just the e, that base, with its exponent. Okay, so isolate, that's important point number 1. Secondly, now I need to use the inverse property. So I need to get the t, that variable, not trapped as an exponent. So I need to get rid of the e. I need to do the inverse property. So I'm going to take the log of both sides. Specifically, since the base of the exponent is e, I'm going to use the natural log. So natural log of both sides, the natural log and the base e, those are inverses, so they undo. I'll just be left with a negative 0.04t. And then I got to calculate the natural log of this decimal. All right, and then no exponents are left, so now it's just a single algebra step, divide to get rid of that negative 0.04t. Final answer of 36.96. More decimal places are involved. The directions ask me to round to the nearest whole minute, so it's going to be 37 minutes. Final answer.